All right, what do I got going on here? I've got, has a revolutions per second. I have a feeling I'm going to have to convert that. We have a time of 12 seconds that it came to a stop, so it's slowing down. And they gave us a moment of inertia. So, you guys know me, I always go to the equation that I need to solve for first. They want frictional torque, so it's torque. I'm going to guess that it's this equation that I'm going to rearrange to acceleration times moment of inertia. We don't have an acceleration, but we know that it has a revolution per second that I can turn into radian per second and then do acceleration of it stopped in 12 seconds. So I'm going to come over here and use acceleration as change in angular velocity divided by time. Guess what I need? I need angular velocity. I don't have angular velocity, I have revolutions per second, which should be pretty easy. So take the number you don't like, 0.72 revolutions. I better leave room so I can do that. In 1 second, I'm already in seconds, so this is good. 1 revolution is 2 pi radians. But by revolutions. And if you multiply that out, you should get 4.5 radians per second. So now I can stick that up here into my change in velocity. It was going 4.5 and then it came to a stop. So the change is 4.5 and this happened in 12 seconds. Why do I always do this where there's not a lot of room? So 4.5 divided by 12, you should get 0.38 radians per second squared. It's going to be negative because it came to a stop. If I would have done final minus initial, this would have been negative. That's how I get negative out of there. Sometimes you just got to think it through. So my acceleration, we just decided, was negative 0.38 radians per second squared. Need to multiply that by the moment of inertia, which they gave us up here, of 0.30 kg times m squared. Throw that. Why is it negative? Because the torque is going to be acting opposite of the way the frictional torque, opposite of motion, so it's slowing down. Throw those two numbers in your calculator. You should get about a 0.11 Newton meters, which probably makes sense if it happened in 12 seconds. That's a long time, 12 seconds. So not a lot of friction there to stop it. Hey, we're done. Woo-woo!